So, hello, JEE warriors. As I have promised, today I have come up with a good level of advanced question from laws of motion, which is a physics concept. And now, it is an interesting question actually. The question seems very small. Question speaks very small. The content speaks very easy, but the process inside this question was kind of a good conceptual based question that you could ever feel it on this laws of motion, because it was a common question in laws of motion, but it feels more conceptually based than solving part. If you could understand the concept, then solving part is way easier. So let me give you a short explanation of this question. So first, let's draw the blocks that is given in the question actually. And so this is the block, and it was a spring that is given. And this is block M1. This is block M2. From not wrong. Okay, wait. Let me get you a good spray, because the spray doesn't even look like a spray. Okay. Let me have a red spring. Okay, this is okay. Now the question is, let's figure out what the question says, because whenever I see a diagrammatic question, first I always used to draw the diagrams. Instead of going into the question, I just draw the diagram and see what is the diagram says to me. And now the diagram doesn't say anything to me, because it's a common diagram. It's a diagram, if it's something that is peculiar, I can infer something from the diagram, but it is common, right? It's just a two block system with a spring. Let's see what the question says. Okay, let's go to the highlighter. Following figure shows, what's the size of the highlighter? The following figure shows two blocks of masses M1. Following figure shows two blocks of masses M1 and M2 placed on a smooth horizontal surface. So smooth horizontal surface. So the first thing was I could infer something from this concept is that it's a frictionless table. So it's a frictionless. It's frictionless. Okay. The next. Let's go to the next one. They are connected by an ideal spring. Of stiffness K. The spring is at its natural length. Okay. Now a constant pulling force F, as shown, starts acting on M2. Okay. This they are saying about this force. Okay. Then we should find the maximum elongation in the spring. Find the maximum elongation in the spring. So what we should find is simple. We should find what is oh my god, this is the change of pen to highlighter was first. Okay, we should find the K max. That's the thing that we should find. That's it. So this is the question that says we should find K max. Okay, let's do the question. So I guess you guys have understood the question properly. Okay. See, forget something. So see, what you mean by a force that is pulling M2 towards it. It is acting horizontally. Okay. The current when ideal spring is stiffness K. The spring has its natural length. So the spring is at its natural length. So nothing to worry about that spring. Now a constant pulling force F showing acts on M2. Find the maximum elongation. That's the question. Now let's deep dive into the question. So first, you should understand something. Some good cases. I would never suggest you to just write the equation. Just go to the laws of equation or the motion equation. No, understand the concept. Now, in 3 to 4 minutes, I'm here to help you with the concept that is involved in the question. You may be unclear with it, or I may be unclear with the explanation because it is quite collapsing concept. But if you are unclear, I would recommend you to stop the video once and play it twice or thrice, please. Okay. So the concept that is involved here is first, if you pull M2 towards you with the force of F, if we pull M2 with force with F, so it accelerates in the direction of force. It means that I don't want to accelerate, so it accelerates in the direction of force. It means that increases the length of the spring or not. Yes. What is going to happen if you pull this way? It's common sense that the length of the spring is going to be increased. Okay, but until what time it increases? Until which standard? Until which point it is going to increase? That is the thing you should know. If you find out that, then this question is going to be easy peasy quiz. It's easy. Okay, let's see until what point it's going to increase. See, the velocity of M2 is this way, right? The velocity of M2 is this way. If I name something called VR or V12, which is velocity of the block 2 with respect to block 1. Okay, velocity of block 2 with respect to block 1. If this velocity increases, then the elongation is going to increase. Elongation is going to increase because the restoring force on the spring. The restoring force on the spring makes M1 to move in the same direction of M2. Am I right or wrong? See, the M1 is still at rest. When M1 is going to move at that, let's make it simple. I'm not going to play with velocity words or something. It's same. Until now, the M1 is just sitting on his table and having a sip of tea. M2 we are pulling with the force of F. Now the spring starts to elongate until how much? The maximum elongation is how much? I don't know, but I know at what point the maximum elongation happens. At what point maximum elongation happens? Until the point where the velocity of M1 is going to oppose the velocity of M2. So this is conceptual based. It means that velocity of 1, 2 is 0. What does that mean? Velocity of block M2 with respect to M1 becomes 0. At that point of time, the elongation of the spring is maximum. Why? Because until that time the spring is restoring its force, but when the velocity becomes 0, it means that when block M1 starts moving opposing it, the elongation becomes maximum and starts to pull towards it. So we can infer some good knowledge from this. So first thing is that, what can we infer that? First thing we can say that when velocity of block 1 with respect to 2 or with respect to 1 is 0, elongation is maximum. Elongation is maximum. So this is enough for me. Now let's dive into the question. Now it's easy to solve the question. Okay, where do I go? Let's solve the question. To solve the question, let's draw the FBD of two blocks, both the blocks. Okay, so let's take block M1 and this is block M2. So M2 is experiencing a force. So the acceleration of m2 is along this side, it's a2. Okay, so the spring force along is kx. The acceleration of a2 is along a1 is along this side, because until a1 moves, the spring is getting around it. When a1 sorry, until m1 moves, see, for example, if m1 is resting, if m1 is rest at 4.00 second and m1 starts moving at 4.00001 second, then at 4th second the length of the spring is maximum. You can get it. When until m1 is at rest, and the next frame when m1 starts to move, then the previous bit of frame is the elongation, that is maximum elongation of the spring. I guess you can get some idea now. So at that point of time only, the velocity with respect to m1 and velocity with respect to m1 and m2 is 0. Okay, so and now, so that's clear now. So for this is kx. For this block, this is kx. That's it. For if I want to make sense, I want to write acceleration for block 1. a1 is equal to what? a1 is just kx, that is force acting is kx by m1. Okay, a2 is, what is the force acting? What is the force that is acting along the direction of acceleration, which is f? So that is f. So f minus kx divided by m2. Quite good. Then that's it. Now let us define a term, because I am taking everything with respect to that, and that respect to this being m1 respect to m2 and m2 respect to m1. So now let's take a term called AR, which is A1 A2. So AR is equal to A1 minus A2 or A2 minus A1. So A2 minus A1, let's take this case. AR is equal to A2 minus A1. Then that means that F minus kx by m2 minus kx by m1. Okay, this is clear. You are clear. Now what next? Next thing is velocity. Velocity v dv by dx is what? What is d? V is dx by dt. What is then dv by dx? Dx cancel, which is equal to a. So I can write a r is equal to v r dv by dx. Nice. Does it sounds very good? Okay, then what should I write? This is equal to, already I have an equation for AR. This is the equation that I have for AR, right? So just plug into the equation. Just plug into the question, which is equal to F minus kx by m2 minus kx by m1. Then what? Separate some terms so that it makes easy, so it is easier to integrate. Separate like this. Is it okay? F by m2 minus, if you take common, and k if you take common, this kx if you take common. Okay, it is okay. Wait. If I take kx also common from both the term, minus kx, then it is 1 by m2 plus 1 by m1. Okay, because this minus goes inside. Calculations you might get it. Then which is equal to yeah, that's it. Here we have dv by dx, right? V dv, let's send dx that side. So f by m2 dx minus kx dx into, multiply this, take MCM, m1 plus m2 divided by m1 m2. Nice, simple. See, you can understand this step, right? I just send dx to this side. I just send dx this side, so that I can get into this, so that I get into this equation. So next, what's next? I guess you guys have concluded what's next. Nothing, just integrate from what to, but what's the limit? Always just starts from 0 0 0. Velocity is at 0, x position is at 0, x it's at 0 because they are given its natural length, so it is 0. Elongation doesn't matter, but what is the final velocity? That's your cup of tea. What is the final velocity? Just remember what I said before. If you could get that point, then you are the one who's going to lead the game of a JEE Advanced. What is the final velocity in this case? 3, 2, 1. Okay. The final velocity, surprisingly, 0. Here elongation is max, x max. Yeah, x max. But brother, why is it 0? Bro, I have already said that relative velocity was 0. At that point, the elongation is maximum. So this complete set of questions, we're just taking relative acceleration. You might see that. What is this R? What does the R denotes? Relative. Then why doubting yourself? Yeah. So the final velocity is 0. At that point, what is the case? At that point, it is maximum elongation. So this whole equation is 0. This whole equation is 0. This whole equation is 0. Then what next? So 0 is equal to f by m2 comes outside. It's x maximum. Am I right? Yeah, am I right or wrong? Yeah, brother, you're right. F by m2 comes outside. Then what? Then in this term, what comes outside? K come outside. M1 m2 come outside. So it's minus, right? It's minus. K comes outside. K into m1 plus m2 divided by m1 m2 comes outside. Integral of x dx is equal to what? X squared by 2. So which is x squared by 2. So as I can straightly put the xm, so which is xm squared by 2. Now send something that side. So what will you get? So what will you get? We want xm, right? Not xm. So f by m2 xm is equal to k m1 plus m2 divided by m1 m2 xm square by 2. Cancel an xm, another xm, and send all the steps except xm here. So that remains us f by m2 f by m2 divided by k m1 plus m2 and m1 m2 into what? Into 2. Okay, into 2. But and yeah, let's cancel this m2 here, and what we get is equal to 2f m1 divided by what? k m1 plus m2, and at last we have arrived at our so-called solution. Yes, see how good this question. When you first enter this question, you may think that, oh my god, what an easy question. It's a mains level question, brother. If it is a mains level question, why would I say this advanced? Because this many would have not understand solution as of now. Please go through the video once or twice. I would strongly recommend that. This type of question is very important. This type of question helps very important. It's a basic level question of advance. So in our upcoming videos, let's solve some good amount of advanced plus mains question of maths, plus chemistry, physics. Don't worry, I'm here to help you with some good questions which I solve a day. If I found some good questions, I will take it to you. So just see the solution. This is what we have done. Okay, this is not advanced. This is quite good at advancce. Advanced is still there, so we are still digging out some good questions. Okay, well then, thank you from your JEE aspirant Harish. Thank you.